Hello everyone, welcome to WSO2 API Manager Community Call 6th session. I am Sachini De Silva and I am a software engineer at WSO2 API Manager team. Today's topic is troubleshooting API requests with open tracing, and here we will have a demonstration on request tracing in WSO2 API Manager via Jaeger tracer, and another demonstration on tracing requests in Microgateway using Zipkin tracer. And as usual, we hope to have an open discussion at the end of this session. So next, quick recap on what we discussed in the last community call. There we basically had several demonstrations on APIM throttling capabilities and a discussion about microgateway questions from the fourth community call. So having told those facts, we will now move on to today's topic. Distributed tracing is basically monitoring applications built on microservices architecture. In distributed systems, requests will go through multiple services which perform one or more operations as those requests pass by. In case of an error in a diverse system like that, it would be a tedious task to track down the issue using log entries scattered over multiple logs. So the solution for this is to instrument the services such that the messages that flow through the system can be traced end to end using a convenient tool. Open tracing is the specification that allows developers to instrument their application code in a vendor-neutral manner. So instrumenting can be done by placing trace statements at strategically important locations in the code. So in API Manager, we have instrumented the basic APIM call flow, including the key validation. Next, we will move on to the first key topic in today's session, which is distributed tracing into the demonstration with Jaeger. I will first explain how to enable end-to-end tracing by extending the tracing capabilities into your clients and backend services. In open tracing, span context can be sent over to different services through a carrier. In API Manager, we use an HTTP header type text map carrier to do that. So once you have added the traces in your client applications, you have to inject the span context into the HTTP header text map carrier and send them along with the request to API Manager. So basically in Jaeger, this will mean that you have to pass the Uber trace ID header along with your request to API Manager. API Manager will identify this, set the span context passed along as the parent span of the API latency span started in API Manager. This is highlighted in key points 1 and 2. So when tracing is enabled, APIM will by default send the tracer headers to backend. So in the backend, we have to extract the trace details from the received headers and set the extracted span context as the parent span for the span initiated in the backend. As you see, this point is highlighted in 3 and 4. Once you have done these parent-child span context mappings, you will be able to easily extract a trace for an API call as shown in this next slide. Next, we will see a quick demonstration on how to troubleshoot problematic scenario using this tool. So we will now see a quick demonstration on how to troubleshoot a problematic scenario using this Jaeger tracer tool. So as I said before, I have already started the Jaeger tracer, my API Manager server, and the back a client to make the API call. And in case I receive a response, it will be logged here in the console. And it seems that the request is taking a little longer than usual to receive the response. So we'll wait. Okay, I received the response now, but we could see that there was a delay in receiving the response. So now I'm wondering where the issue was, whether it was in the API Manager or my backend service, which caused this delay. So since we have enabled Jaeger tracing in API Manager, we can go and check this in the Jaeger UI. So here I created the trace related to the most recent API call I made. And if we go and explore this, we can see that this test span 80 seconds. So obviously this is too much for the simple hello service I have implemented. So now I can deduce that there is really something wrong in the backend. Having figured that out, I will now go and fix it. So as you can see, for this demonstration purpose, I have intentionally added the thread sleep. In an actual error scenario, you will have to go through the service, identify the actual issue and fix it. Tracing will help to isolate the component that caused the issue. So for this demonstration purpose, I will just remove the thread sleep and start the server again. Okay, the server started. So now we will make an API call again and see whether the issue is fixed. Okay, so now as you can see, we got the response almost instantly. So if we go back to Jaeger tracer and explore the if we explore the trace related to the most recent API call, yes. Now the backend is taking only 0.8 milliseconds to respond. So we can see the backend issue is fixed now. So that's it about troubleshooting API requests in WSO2 API Manager. Next, we will move on to microgateway aspects. Okay, instrumentation basics for the client and the backend service are pretty much the same in microgateway as well. I have shown it through the diagram here. So in this case, we can directly move on to the demonstration. But here for a change, I will be using Zipkin as the tracer for microgateway. Jaeger tracing is supported by default in the default ballerina distribution, but Zipkin is not. So we have to add some additional Zipkin dependencies to our project before we build it. For that, we will have to build this ballerina observability repo, and we have to get the distribution zip from the Ballerina Zipkin extension modules target folder in this location. After you build this repo successfully, you can see this distribution zip inside the created target folder. So then you have to extract the zip, get the jars inside it, and copy those jars into your Microgateway project's lib folder. So as you can see, I have done that already. And after copying these jars to your Microgateway project, you can build the Microgateway project. So apart from that, there's one more thing to do to enable tracing in Microgateway. That is, you have to Zipkin tracing related configuration the Microgateway runtime. Here in my local setup, I have already done those configurations and building the Microgateway jar. I already have a Zipkin server running and my gateway running. So I will make an API call to the API exposed in the Microgateway. And I received a successful response. So now if we go to the Zipkin UI, and filter out the trace related to our API call. Yes, I have filtered the trace related to the API call here. So you can see that there are spans added from the Microgateway client and the backend service. So if we go and explore this in the spans added by the Microgateway, you can see details about the resource being called, and there are some other details carried in the span tags. So like we did with API Manager, we can easily track down problems once we have added proper instrumentation to clients and backends in Microgateway as well. Okay, so that's it for the Microgateway demonstration, and with that we come to the end of today's topic, and we are good to move on to the open discussion. So now if you have been requested to share the API Manager or Microgateway, you can ask them from the teams. I will show you. This is the backend service. This is the hello service I'm calling, and here I am here I have an init tracer, and in that I am instantiating Jaeger tracer, and I am registering it to the global tracer. Then in the my service, I am getting the tracer, and I extract the span context from the headers. Here as you can see, I'm receiving the headers from the API Manager server and adding them into a trace specific carrier, and then I'm passing it to this tracer.extract method in order to extract the span context passed from the API Manager. And then when building the backend span, I am setting the extracted span I am creating the backend span as a child span of the extracted span. So that is it about the implementation in the backend service. So similarly in the client, which I am using to make the API call, here I am starting the super parent span, which is the client span, and then I am getting the context from that span. And before sending the request to API Manager, I inject the span context details into a tracer specific carrier, which is in this case string map. And then I iterate through the tracer specific carrier and add all those headers into HTTP headers. And I'm making the API Manager request along with those headers. So we will be uploading a sample client and a backend service to GitHub, and we'll be sharing the GitHub links in Slack. So I think that will answer the query. So as the time is also running out, I think now we are good to wind up this session. So before winding up, I would like to once again remind about the webinar on gRPC support with API Microgateway 3.1. It is to be started now at 9:30 p.m. IST. So our next community call in May. Hope to see you all again. If you have any suggestions for the community call, please add them to this form. You can be in touch with API Manager community through Slack, Twitter, and email. We will be uploading this session to YouTube as well. So thank you all for joining. Thank you.